Today I'll be covering conductors and capacitors. A conductor is an object or material that allows electric charge to pass through it easily. So for example, a conductor might look like this in a diagram where charge is evenly spread throughout the surface. Some characteristics of a conductor include free electrons or electrons that can move around. Additionally, due to the even spread of charges throughout the surface, the internal electric field is equal to zero. And for the same reason, electric potential internally is constant and non-zero. A capacitor is a device that stores electrical energy, and it looks like this in a circuit diagram. A key characteristic is that no electrons or current pass through it. Instead, you have a positive and negative plate, and electrons are pulled away from the positive side and accumulate towards the negative side. Dielectrics are an insulator placed between capacitor plates. They're represented by the dielectric constant kappa, and they're used to increase capacitance and stored energy. Some relevant equations for capacitors include the equations for capacitance. There's a definition for capacitance or charge over voltage, and there's one that includes area and the distance between the parallel plates. Additionally, you can rearrange the original expression to solve for charge and voltage. There are also equations for energy. So for example, we start with the base equation 1/2 capacitance voltage squared, and using the definition for capacitance rearranged, we can get two new equations. And finally, we have equivalent capacitance equations, which are very similar to resistance ones except they're just swapped around. Now let's do some practice problems. Pause the video and read the problem. Well, since we're in equilibrium, we know that the voltage has to be the same for both conductors. And rearranging, we can get an expression for Q1. And substituting in our known values for radiuses, we can get an expression for Q2. And also, due to conservation of charge, we know that Q1 plus Q2 has to equal 60 microcoulombs. And since we have two equations and two variables, we can solve for each variable. Let's do another practice problem. Pause and read the problem. Well, since we're given the distance and capacitance, we know that we have to use an equation that includes distance and capacitance. And solving for area and substituting in our known values, we get 5.65 meters squared. For part 2, we can just rearrange the definitions for capacitance to solve for charge and substitute in our known values, getting 1.5 microcoulombs. Thank you guys for watching.